Hello, everyone. We're still on lesson 6.5. This time, I'll go over an example on inverse matrix. Okay, before we start, let's recall something. Okay, remember, for example, I have a real number A. Okay, this is a review, from your previous math. If I have a real number A could be anything, and I multiply that by x, and x is equals, a times x is equals to 1, then I'm trying to solve for x. I'm going to find a solution for x. Then of course what we normally do in algebra 1 is divide by a, right? So a cancels, so your x now is equals to 1 over a. And then if you look at this expression, 1 over a, this is also the same as a raised to negative 1. Correct? And a raised to negative 1, in other words, you call this inverse. This is a symbol for inverse. We have a function, f of x. Let's say our function is f of x, and you want to find the inverse of this function, f of x. The symbol you're going to use is f raised to negative 1 of x. F to the negative 1, you're going to write this symbol. So this is now the inverse, how you write the inverse. Okay, so in terms now of matrix, so if you have a matrix A, so for matrix now, let's say you have a matrix A, and you multiply that by x, and then it's equals to matrix I. Matrix A times matrix X will give you matrix I, which is an identity, correct? So then you're going to say X equals 1 over I over I over A. Yeah? Well, this is an identity. Therefore, we can say that another way of writing this is, we can say that A times A inverse. Okay, so we can, this one will say like that. Okay, A raised to negative 1. So A, or A inverse. So if we want to check if this is really the inverse of A inverse, A raised to negative 1, or A inverse times A, if it will give you I, which is, of course, if it's a 2 by 2, 1 0 0 1, it look this how the I would look like. It's an identity matrix, then they are inverses of each other. Okay, so that's what we're gonna do today. Okay, example for this. Example, I have a matrix A, and that is a 2 by 2 matrix. We have 1 2 and then 4 6, and I have matrix B, another 2 by 2 matrix, negative 3 1 and then 2, then negative 1 half. Okay, I want to determine I want to determine whether matrix B is the inverse of A. So therefore, this is your A. We can say this is your A inverse. And we're going to use this concept right here at the top. If I multiply matrix A with matrix B, and if I get an identity matrix which looks like this, that means matrix B is the inverse of matrix A. Okay, so that's what we're gonna do. We will multiply A matrix A times matrix B. Well, can we multiply? Let's check. 2 by 2, 2 by 2. Two equals 2, so yes. And the product, of course, is a 2 by 2. So meaning we can multiply it. And be sure we're getting a 2 by 2 matrix. So A times B. Okay. 1, 2, 4, 6 times negative 3, 1, 2, negative 1 half. Of course, I'm gonna get a 2 by 2. Okay, I'm gonna get a 2 by 2 matrix. So let's start. Row 1 times column 1. Row 1 times column 1. So I'm gonna use this. Row 1 times column 1. Okay, so 1 times negative 3 plus 2 times 2. And 1 times negative 3 is negative 3 plus 2 times 2 is 4. Negative 3 plus 4 is 1. So row 1, column 1 is 1. Okay, next. Row 1 times column 2. Row 1 times column 2. Row 1 times column 2. 1 times 1 plus 2 times negative 1 half. 1 times 1 is 1. 2 times negative 1 half is negative 1. So 1 plus negative 1 is a 0. So row 1, column 2 is 0. Okay, next. Row 2, column 1. Row 2 times column 1. Row 2, column 1. So I have now 4 times negative 3 plus 6 times 2. Well, 4 times negative 3 is negative 12. And then 6 times 2 is 12. So that is a 0. So row 2, column 1 is 0. Okay, next. Row 2 times column 2. Row 2, column 2. So 4 times 1 plus 6 times negative 1 half. Well, 4 times 1 is 4. 6 times negative 1 half is negative 3. 4 plus negative 3 is a 1. So row 2, column 2 is 1. So the answer is a 2 by 2, 1, 0, 0, 1. Since we got an identity matrix, that means, so thus, because we got this as our product, thus B is an inverse of matrix A. Okay guys, hope you understand, and don't forget to subscribe.